What is scientific notation? It is a way to write either very large numbers or very small numbers in ways that make it easier to read. It is used a lot in science because of small, maybe when you're talking about atoms, or very, very large numbers like distance to the stars and things like that. So the rule is that the first number has to be a number that is between 1 and less than 10. So like I'm just going to say 9.9. I always just think of it as there's one digit to the left of the decimal point. So 1 point something all the way up to 9 point something. Then it's multiplied by 10 to some power. What that means is when you have a number that you're going to multiply by 10 to some power, that basically just moves the decimal point. So if I take 3.25 and I actually multiply it by 10, it starts to move the decimal point. Well, if I'm going to take it times 6 tens, then I'm going to move the decimal point 6 places. So if it goes 6 places to the right, 1, 2, 3, 4, 5, 6, those extra 4 places turn into zeros. So 3.25 times 10 to the 6 actually becomes this number, which you can see is 3,250,000. Let's do one more. So we'll change it from, let's say we have 4.6 times 10 to the 4th. So I'm moving the decimal place 4 places, while the 6 will take up one of the places, and then I'll need 3 more places of zeros. So 4, 6, 0, 0, 0. So it's actually 46,000. Now, a negative exponent is going to make it a very small number. So if I have 2.5 times 10 to the negative, let's say 4, now I'm dividing by 10. Well, that still moves the decimal place each time I divide by a 10, and I'm dividing by 4 tens. So I'm going to move that decimal place and make it a small number. So it's going to go that way 4 places. The 2 will take up the first place, and then I'll have to fill it in with 3 zeros. So my decimal point ends up here. Oh, I'm sorry. And then that's the number. So 2.5 times 10 to the negative 4 is actually 0.00025. If I want to write a standard form number, meaning a number that looks normal, let's say I have 92 million. I want to make this into a scientific notation number. So I know I want to move the decimal point all the way back to in between the 9 and the 2, because that was the rule. You have to have a number from 1 point something all the way up to 9.9. So we're going to turn it into 9.2 times 10 to some power. Well, to get that power, I'm going to count. So I moved it 1, 2, 3, 4, 5, 6, 7. I moved it across 7 digits. So my exponent of my 10 is 7. I started with a large number, then my exponent's going to be a positive exponent. Let's start with a small number this time. So let's say we start with 0.00786. So I know I want to move the decimal point so that I have 1 digit to the left of the decimal point, not including 0. So I'm going to be moving that decimal point all the way between the 7 and the 8. So we're going to end up with 7.86. I started with a very small number, so I know I'm going to have a negative exponent. Negative exponents make small numbers. So how many times did we move it? We moved it 1, 2, 3 places. So 7.00786 becomes 7.86 times 10 to the negative third.